Hello everyone. In this video, we'll continue exploring the evaluation concept of LangSmith. Just as a quick recap of what we learned in the previous video, we had previously built a ground truth dataset consisting of pairs of questions and answers. Now, when you test your LLM app, the version V1 of the app on this dataset, it gives you certain metrics. Now you can change the underlying prompts, model or architecture, and when you test this, it gives you a different set of metrics now. These are in essence the experiments that are run on different versions of your LLM app. And these metrics are called evaluators in the context of LangSmith. And the way this is found out is you have your golden dataset having the input and reference output. Using the same input, you run your experiment using a version of the model that gives you the run output. And for the metrics, you take in the input, reference output, and the run output, and the outputs are compared against the input. The two outputs are compared to evaluate the metrics. Now, for this video, we'll look at how these particular experiments are run to calculate the evaluators. Going back, we had this ground truth data set. In fact, in the previous video, we had built three evaluators: correctness and conciseness based out of LLM as a judge, and conciseness based out of code. One thing to note here is, if you have been following the other videos in this series, we had initially started with this as the master dataset and built some evaluators, added new examples. But for some reason, the examples kept getting getting failed, probably due to the underlying schema. So we also had built a duplicate dataset at the time. So I sort of created new examples and evaluators in this. So there's a possibility that some of the titles or description are quite different from what we have seen in the other videos, but the core concepts and the examples are pretty much the same. So with that, let's now go into experiments and run experiments for this dataset on these examples based on these evaluators, right? So you have your master dataset, examples within these datasets, some evaluators attached to this, and right now we're going to run the experiments. So you can go, right now it says there's no experiments here. You can go to the experiment tab. There are three different ways to do it. We can explore these two sometime in the future, but we'll try now or test it using the Python code. So you install the dependencies, configure the environment variables, and this is where you import the dataset and evaluate. Let's copy this and go to our VS Code. So I have my RAG based application, and it's the same in the previous video. It's for a cafe chatbot. So this is the function that's calling the RAG application and returning the answer. So we have this piece of code that lets us evaluate this dataset against the evaluators for the given examples. So I had imported this already, so let me remove this. You are initiating the client and mentioning the dataset name. Now this dataset name is filled by default. This is the name we have given. Since we have copied it from there, it's already been populated. Next step, you define an evaluator. Now by default, you don't have to mention this. By default, whatever evaluator has been assigned to this dataset gets added, or it is evaluated based on these metrics. But in addition to that, you can also add some new evaluators on your own. For this example, we'll skip this part. And finally, you run the evaluation using the evaluate function, right? So the first thing you have to do is put in the function that is the actual function call. In this case, it's the run RAG, and then you mention your dataset name and evaluators. Now in this case, we're not adding any evaluators, so by default it's going to take in all the evaluators that we have attached here. And then finally an experiment prefix. Let's call it experiment 1, right? And just run this. It's going to evaluate on, I guess, 17 examples. You can see the time it takes. We can give it some time. So if we go to the experiments tab, this has started populating. So as and when we see the examples getting evaluated, it comes up here. At the moment, you can see how examples like conciseness or current correctness are blank, because what happens is, under the hood, first, for the input, this particular output is being generated. So this is one LLM working. After these are generated, another LLM compares these outputs with the input and then calculates the metric. So that takes a separate run, right? And additional latency and runtime. So all of this is happening behind the hood and it takes some time to process. So that's why we aren't able to see the results at the moment. So we'll come to this in the end. But for time being, let's go back here. We can see that it took what, about 18 seconds for the 17 iteration. You can see the inputs, outputs, and reference outputs, and some more details, right? But a detailed view of all this is obviously in within LangSmith. We'll come to this later, but let's look at what are the other things that we can do within LangSmith. One thing is, of course, let's if you go to the top, this model was based on GPT 4.0, but let's change it to GPT Turbo 3.5. I think it's a cheaper and faster model. So if and all the other things are same, right? I have the same function, same data set. I've changed the experiment prefix here. Now if I run this, um, it is going to take a time, but let's move on and see what are the other possibilities. Now when we built the data set, we saw how we can split the data set, right? If you go here, you can see how we had like a base version, and we also selected some important splits. These could be those examples that you want your test to absolutely pass. So we have the master split as well. So what I can do is I can mention master here. So instead of giving data and dataset name directly, as in the previous case, um, dataset name directly, we use this particular function where we're listing some examples from the master dataset. So the split I've mentioned here is includes 5 examples. So that should iterate for 5 times. There you go, just 5 examples. What you could also do is um, include specific example IDs. Let's say going back here to examples, let's say this one, right? Now this has this example ID. I can copy this and paste it here. Let's do one more, maybe this one. Copy the example ID and paste it here. So if you want to check your outputs on some specific examples, you could do so using the example IDs. And as you can see, this has tested or evaluated on the two particular examples. One more thing is you can do is to evaluate the examples multiple times. This is because LLMs don't give the same output each time, right? Uh, they're not sort of deterministic. So there's a possibility that sometimes it passes the test, but maybe the other time it doesn't, or maybe it doesn't the first time, and there's a possibility it does the next time. So you want to maybe run more than once to ensure it is working fine. So here I've given 2. By default it's 1, as in the above cases. So when I do here, I think we have 17 examples, right? So in essence we should get 34 iterations. It's gonna take some time. Let's go to the next one. This is concurrency. So um, you can sort of parallel process multiple examples at the same time, but obviously here you need to make sure that it does not hit your rate limits for the model. So you can probably want to test it out. Let's say let's go for 2 actually, and see if there is an improvement in the. Oh, that was quick, right? Does it say 31 seconds? Hmm. Oh wait, sorry. This was the previous example where the number of repetitions were 2, right? So this has evaluated for 34 examples, twice for each. But yeah, when I say concurrency 2, I think we had about 15 or 16 seconds when we evaluated earlier. But right now, parallel processing has brought it down by 50%. And these are the same examples, right? Just that they have been processed two at once. And finally, you can include some metadata within your um, model, within your evaluation. So here I could include some model names or the kind of, I don't know, like a specific user who's testing this and so on. So all this will give me the necessary information. But right now we can go back to LangSmith. While the last one is populating, I think some of the other examples might have um, we might have got the result. Oops. Let's hope the details are fine. So as you can see, we can already see some things populated here. There are some failures. We'll look at what that is. Some graphs here. We'll look at each of them. But let's start with the first example, right? Um, Hopefully the details are populated now. Yeah. So first thing we can see here is obviously the heading. So by default you get an ID. We also chose to have a sort of prefix to it to help filter and um, isolate it better. And you can obviously go and rename it again. Oops, what did I do? Yeah. You can download the dataset. Sorry, download the evaluated metrics. Change the view. This would be compact view, directly looking at the details. A full view would give us some more detailed view of the inputs and outputs. Difference would show us what the difference is between the reference output and outputs. In this case, it's not quite important, but there's the obviously specific use cases where you're looking for exact match, and there you'll know what the difference is. In the display, you get to see um, um, what the fields are in which one you want to look at. So let's select all for now. Um, and So the thing is, all of this are also traced under the tracing projects, right? So you can look at all of them and look at what the individual run was. In fact, if you go into the tracing projects, we had the specific projects previously, but there is a new sort of project created called evaluators that has all the specific runs within the evaluations that we do. So that's what you we looked at there. Um, but going back, we can look at specific examples. Now, if we click on this, we can see what this example was in terms of the input and output. But we can also look at the linked runs, which says where this particular was used across. So there could be different tests at different points of times across different versions of the app. So all of this helps us know how this particular example performed in the other use cases. Um, but yeah, moving forward, we can also look at the reference outputs. This output is what has come out of the app. And across this, right, we also have an option of seeing the detailed view. So that this gives the same in a more um, no with a detailed view of all the of three parameters. Um, but for this output generated from the LLM, we can obviously go back into the trace and see the kind of flow across the different components. This is effectively the same as when we did a typical RAG application, but here this is linked to the evaluation. Um, but otherwise it's the same. When we go into the metrics now, we had the conciseness and correctness, both LLM based. Um, so here it outputs the exact score, 9 being its verbose, I guess. Yeah, higher the score, more verbose it is. Um, So here it says the score, but once we go in, these are again individual LLM runs, right? Because it's LLM based, LLM as a judge. So it's going to compare the three values to finally give the consciousness score. So here, as you can see, it has the inputs and outputs, but in the final output, it has these sort of LLM based judgment. And if you remember from the previous video, these are in essence uh, the kind of rubric and instructions we had provided. So it has evaluated based on things, unnecessary elements, redundant in some places. Overall assessment is clear, direct, and mostly minimal with one small avoidable lead in, and so on. Thus, the score should be 9 out of 10. And finally, it has scored 9. And that's what you see here, but individually you can see what kind of evaluation has been done under the hood, and you can obviously look at correctness. Again, individually it will tell you if what details have been correct. The models on the states, this one, this score should be true, and so on. Let's look at some incorrect examples, right? What was this question? Are there gluten-free options available? So the correct output should have been, we have, let's go into this actually. Yes, we have gluten-free cookies and gluten-free pasta. Right. So here there are gluten-free options available, such as gluten-free brownies. So here it says cookies, here it says brownies, but there's no mention of pasta salad, right? Um, and when I speak of correctness, this is what it should have pointed out to. We can go into the detail. The output answers yes, which directly addresses the question, but gives an example, gluten-free brownies, that does not match the reference output, which lists gluten-free cookies, right? And salad. So it has output false here, and which is why we get a score of 0. So this is how you can compare the kind of metrics, right, based on what you expect and what the model is actually running. Now, the I think this exact match can be ignored here. This was based for another experiment, which is why it is also showing up here. But this particular metric, feedback key, was actually our, if you go back to the evaluators, it's the code-based um, evaluator we built. The reason it's failing is because we sort of used these examples from the test code, right? We directly used column names like run and outputs, but this does not match the actual schema of the data we are experimenting with, which is why it has failed consistently across all the test runs. But yeah, I think if we correct that, then that should give us an appropriate answer. But yeah, going back here, you have other details like latency, completion, tokens, cost, and the other usual metrics, right? But these are the important ones, the metrics or the evaluators that you are running the experiment on. Going back here, it's pretty much the same. You have your experiment here, the split, which is based on repetitions. For this example, we did a couple of repetitions. You can go back here. I think it gives you an average score, right? The first time it scored 8, and next time it scored 9, so it's an average of 8.5, which is good because, right? I don't know. Let's say this example, like first time it scored 3, second time it scored 8. So in effectively, right? At one point we scored 3. That was like poor performance, and 8 is a good performance. So that's how models differ, right? Under the hood, LLM can hallucinate itself, give different answers differently. So we want to make sure we run it multiple times on a given data set so that it sort of averages out. So these are the kind of metrics that you can compare across, right? Now, in this example, we kept the data set pretty much the same. Of course, we use some certain examples to filter them out, but we started with a different model, and then we moved to um, a faster and cheaper model, uh, and but otherwise we pretty much kept the same. But in reality, you can also experiment with different prompts, different architecture, make different changes, and see how the data set, or how the app performs with your golden data set. One thing we can do here is obviously look at the charts. You can filter them. Let's say I want to look at conciseness and correctness. I also want to look at the latency rates. Now, if we remember, this was our first experiment where we used a 4.0 model, and this was the GPT-5 model. Now, looking at the scores, this scored was 7.5, um, and it was 7.5 across both. The correctness is 0.47 and 0.41. So the model did better in the first case. But if you look at latency, uh, here's the catch, right? Um, yeah, GPT-3 5 Turbo was a faster model, which is why the latency is smaller. But that also means that there is a dip in the correctness. So which one do you try to optimize? And these are the kinds of insights that you can derive by using a component like evaluation within LangSmith. So that's pretty much for this video. There are a couple of topics like pairwise experiments and summary experiments, which I'll try and cover in the next bunch of video. But in essence, this is how you can run experiments and evaluate using the evaluators within LangSmith. Thanks for watching this video. I'll see you um, with the next video covering a couple of other topics in LangSmith. Thank you.